Hey guys, welcome back. So in this module, we are going to discuss about linked lists. Okay, so linked lists. So I'm going to tell you what is a linked list and how to implement that using C. Okay, for this you have some prerequisites. Okay, so let me write that also, prerequisites. So first one is you have to be very clear in structures in C, the concept of structures in C, and also self-referential structures. I'll explain about that, and you should also be clear in pointers. Okay, so okay, I'll make two important videos explaining structures and pointers. Please do watch that video if you are not clear with it. After that I'll go to linked list. Okay, but in this module let me explain all the concepts of linked list so that you will be able to understand this. Okay, so okay, what is a linked list first? Okay, I'll explain the concept. A linked list is something that is linked. Okay, so there is no order, guys. You don't have any index. Okay, you don't have any indices like array, indices or indexes. You don't have that like an array. Okay, and each a linked list, each element is called as node. Okay, so each element is called as a node. This is very important, guys. Okay, you should not call that as an element, that is a node. Okay, each element is called as a node. Okay, what is the structure of the node? Assume this is a node. Okay, this is a node, and a node will have two data field, guys. Okay, a node will have at least two data fields. Okay, it can have more than that, but at least two data fields will be there. Okay, at least two fields will be there. One is called a data field. Okay, this one is called as a data field, which will hold the value that you want to hold in a list. Okay, which will hold the value. Another one is called as next field, guys. What it will do, it will hold the address of the next node. Address of the next node. Okay, let me explain this quickly. So this will hold the exact value which you want to store, and this will hold the address of the next node. This next field will hold the address of the next node. Okay, so this is the structure of a node, guys. It has two important fields. What do you mean by address of next node? Let me explain this. Let's say I just wanna store this particular string. I'll go for one particular string. So today is Sunday, so let me go for Sunday. Okay, I don't know, you'll be watching this video on Sunday. Okay, let me go for some other string. I'll go for apple itself. Okay, so apple. So I want to store each character in a in a separate node, guys. How do I do that? Okay, so let me have a first node. Okay, so let me store a here. You know that first data field will always have a value, so you can store a, doesn't matter. I have to store a single character, and this will be having the address of next node, guys. Okay, so it will point to next node. That's the exact word. It will point to next node. Okay, so here you will be having p, and again it may point to next node, and here you will be having again one p is there, right? So p, so again this field will point to the next node, and here you will be having maybe l, and okay, I think there's some. Okay, let me stop with this. Okay, so because there is no space in this display, so let me stop with this. So p, app. Okay, app is also a good word, right? So app. So you have three nodes in this linked list, guys. Node 1, node 2, and node 3. All right, so those three nodes are linked. Okay, are linked. You can see the link here. Okay, these are called as links or next fields. Okay, so those three nodes are linked. That's why this is called as a linked list. Okay, linked list. Okay, this is a very easy concept, guys. I'll explain to you in a very good manner. So here, but what does it have actually? Sir, you're saying that this is linking to the next node. Okay, fine, but what do you have here is the address of the next node, guys. Let's say this node has an address 1001. Okay, address may be a 9-digit number, but let me go with this. Okay, I always assume this, so let's go with this address 1001. So this address of this node will be 1001. Address of this node will maybe 1007. Address of this node is 1015. Okay, and address may not be sequential, guys. In an array if you see each node will have sequential address. This is 1001. If you assume this is 1003, 1005, 1007, 1009, it will have a sequential address, guys. But here it is not like that. Here you will have random addresses, and each address will be of 9 digits, but let me have 4 digits for simplification purpose. So this node's address is 1001, this node's address is 1007, and this node's address is 1015. Okay, the whole node. Okay, now can you tell me, I told you that this particular data field in this node 1 will be helping you to link with the other node. Okay, then what is the value of this data field? Can you guess? Pause the video and guess what is the value of this data field. Okay, I think most of you got it right. This value is 1007 because it points to the next node. Okay, it points to the next node. What is the address of next node? That is 1007, right? So this field will have 1007, guys. Okay, and similarly, can you guess me the value of this node? Yeah, this is nothing but 1015 because it points to the next node, and this will have, the next node has an address 1015, so this will be 1015, guys. You got it right. Then this node is the last node, right? This node is last node, and it doesn't point to anything. You can see it doesn't point to anything. Then what is the purpose of having this? This is called as null, guys. Okay, so last node, always please remember this, the end node will always have the next field to be null. Okay, the end node will always have the next field to be null. Please remember this, guys. Okay, so the idea is very simple, I hope. Okay, so this is the structure of linked list. Alright, so now let me teach you how to create structures in C. Okay, because we are going to define a node as a structure, guys. Okay, so let me teach you some basic concepts in structures. Before that, let me give you the advantage and disadvantage of linked list. Okay, and in linked list we are gonna allocate memory dynamically. Okay, which means that it's pretty dynamic and you can save a lot of memory. Because how do you declare an array, guys? Okay, you declare an array like this, right? Int maybe r size is 50. If you give like this, then the size is fixed, right? The array is 50, the size is 50, and you can't change that. Automatically at the time of declaration itself, for 50 elements memory will be allotted. Okay, say for example I am entering only 5 elements, then you are wasting the 45 locations. Okay, you are wasting those locations, you are wasting the memory. So that's why we say that array is static, guys. Okay, whereas here, as far as linked lists are concerned, it is dynamic, which means you are gonna allocate memory during your program. How to allocate memory, I'll teach you that. During your program you're gonna allocate some memory. Okay, so that's dynamic. Okay, and second point is insertion and deletion is easy. Of course, we have seen insertion and deletion in array itself. Here insertion and deletion is easy, guys, very easy. Okay, it's very easy because you can if you want to insert a node, that's pretty simple. You can give the say for an example, I have two nodes here and these are linked with each other. Okay, so it's pretty simple, guys. If I want to insert a node here, what I have to do is I just have to cut this link, join a new node, and make the new x field of new node pointing here. That's it, right? So I just have to do this to insert a new node. So insertion and deletion becomes very easy, and I'll teach you that. Okay, we'll have to write an algorithm. Fine. So these are some advantages of linked list, I could tell you. But randomly you can't access any node, guys. Okay, so say my linked list has 4 nodes. This is very important point to be understood. My linked list has 4 nodes. Randomly you can't access any node. Okay, say for an example I want to access this node, you can't do that. Okay, I mean directly you can't access that. Okay, you have to start from first node and you have to traverse that. Okay, then only you can access the node. Randomly you can't access the this node and all. It's not possible, right? I think in stack also it's not possible. Okay, if you remember, right? Only in array you can access the elements randomly. In stack or in linked list you can't do that, guys. So that's one of good disadvantages I could talk about, right? So